I want to go through the same set of slides as before. The only thing that's going to change is now, in addition to listing the R squared on the top left, I'm also going to list the adjusted R squared. So I want you to see what happens to it. Now, R squared is always a number between 0 and 1 because it's the proportion of variance explained by the model. Or you could also remember that it's simple correlation squared, and correlation is between -1 and 1. Adjusted R squared doesn't have any boundaries like that. It's still true that the closer to 1 it is, the more you might think your model fits. But watch what happens as I go through these slides. So remember, what we're doing is we're increasing P. So we're adding polynomial terms to this model. Okay. As I add polynomial terms to this model, remember, the curve starts to try to fit the data better and better, and R squared is going to increase. It's going to look like the model is better and better if we watch the R squared. But if you watch the adjusted R squared, it just kind of goes crazy. Remember, it has no interpretation, really. Adjusted R squared doesn't mean anything, but we can see it's now close to 1. So if you were to fit this ridiculous model where the number of parameters is the same as the number of data points, such that you've now made a polynomial that goes through every single data point, clearly this polynomial is not going to be good for making future predictions. Again, like if this is X, right, there's no reason to guess that this number right here would be Y, right? Rather, these data points just are random noise around a flat line. But R squared is saying, hey, what a great model. Adjusted R squared is saying, like, I can't even come up with a number. NaN is not a number, right? And if we put one less term in there, we might have an R squared of 0.8. That looks really strong. Adjusted R squared is negative, which clearly means that it's a terrible model. So adjusted R squared is meant to set off alarms. In most cases, unlike this extreme one I've given you here, adjusted R squared and R squared will be similar to each other. If they're very different from each other, that's a place where you have a sign that there are predictors in the model that are not necessary, because all those unnecessary predictors are increasing R squared, but they're not increasing adjusted R squared. So comparing those two can be useful. Even though R squared is the one that has a real interpretation, adjusted squared doesn't have an interpretation. All it is a warning about whether R squared has increased only because you're adding more predictors to the model, not because you're adding good predictors to the model.